Hello friends, welcome to our channel Knowledge Amplifier. So in our previous video, we discussed the concept of RAG or Retrieval Augmented Generation, and the common pipeline for our RAG generally looks like this. That is, we are having some company's internal text file or documents that can be PDF files, etc. Initially, we split into small chunks and we pass via embedding model. We get the vector representation of chunks. We store in some sort of vector store that can be Pinecone or Elasticsearch, etc. And then suppose user is querying something. As a first step, we will convert this query to vector using embedding model, and then we will try to find out the similar chunks with respect to this query which are available in this vector store using cosine similarity. And once we get that 2 or 3 similar chunks, that we will pass as in-context learning kind of thing via our prompt along with this query vector. So our LLM model will get some understanding from those chunks which we passed with the prompt, and based on that in-context learning, LLM model try to reply. So this is RAG, retrieval, where we are extracting the similar items, augmentation, where retrieved chunks and query we are appending, and when the LLM model is generating response based on that, that is called generation. Okay, right? Now RAG is only this particular part mainly, but this thing we need to implement as a pre-processing step we can consider for any RAG application. But think like this way, if AWS take care of this whole thing on our behalf and we need to focus on only this particular part, then the development time will be very less for any RAG application, and that we can do using several AWS services. One such service we are going to explore today in this video, and that is Amazon Kendra. So what this service is basically, it is nothing but an enterprise search service powered by machine learning. Okay, so here our vector store is doing that thing only, that using cosine similarity try to find out the similar items which are relevant to this query. Same thing Kendra does for any documents. Okay, so the process is like, first we need to create an index, same like in Pinecone also we are creating an index. And now we need to mention that from which data source the index data will be populated. You can consider like how in Pinecone we were ingesting the data from our Python code. Here in Kendra, we need to mention that this is the source system. Maybe that is S3. And in that S3 location, multiple PDF files are available. Kendra will crawl all of them, extract the information and store in index. Okay. And on that index, we can query anything. So once our index is created, index is populated, that is nothing but a vector store. Now we can take care of only this particular part using programming and implement any RAG application using Amazon Kendra, right? So for that, we are going to first create one data source for us, which will be acting as source of information for our Amazon Kendra. And here I can search Snowpark Blue Test. So here you can see this is an empty directory, and here I am going to upload one PDF file. And this is BJP's 2024 manifesto, which is nothing but they are calling as Sankalp Patra, and what all warranty Modi ji is providing for 2024 if they are coming as part of their third term. Those things are mentioned in detail along with their past 10 years tracks. Okay. So this particular document we will try to upload in S3, and on top of this we will be creating a RAG application to ask certain questions and get the answer based on that. Okay. So here I will just upload this Sankalp Patra in my S3 location, and now I will go to Kendra, and first I will create an index. So here I can give the name demo YT test Kendra. Okay, description if you want you can provide something, and here I am going to create a new role name demo YT Kendra 18. KMS key not needed. Tags as of now I am not providing. Use token, no, not needed. User group I am keeping default, and developer edition, because this is a POC, so I am keeping developer edition. And here I will create this index. It is going to take few seconds, so we need to wait for that. And here our index got created. Now this step 1 is done. Now step 2 is add a data source. So it is just like this case. If you consider, first we have created an index in our Pinecone. Now we need to put the data source wherever this text file or PDF files are available, so that it can populate the index for query purpose. Okay. So here now we will add a data source. So we can go to this data source option, and here we are having available data source. That is from where Kendra can read the data and make it available for intelligent query using machine learning. So we are having different connectors, and here I am going to search S3 because in S3 my data is available. Add connector, and here data source name I can provide Here I can give Sankalp Patra. Description we can keep as it is. Default language English. Then click on next. IAM role. So here create a new role I can provide. Role name. So here I have given something virtual private cloud not needed. I am clicking on next. Now here S3 bucket we need to mention. So our S3 bucket is this one. I will copy that and paste here. You can set up maximum file size. So here in this particular case, the size is 22.9 MB. So here I can keep 50, not a problem. Metadata, file prefix, access control, I am keeping all these things default. Now sync mode. So full sync is nothing but full refresh kind of process. And new, modified or deleted content sync, it is nothing but incremental load with respect to our data engineering world, right? So only it will sync whatever newly appeared in our connector or deleted or newly modified, etc. So we want to opt for this option. Anyway, for the first time if we are running, it will be nothing but a full refresh kind of thing. So let it be as it is. Now frequency, I can keep run on demand. So when we will click on sync now, then only it will sync. And if you make it run on demand using some Python code, using Boto 3 also, you can automate or trigger based on certain event. All those mechanisms you can implement. And then you can click on next, and here next, and we can click on add a data source. Okay. So it is going to take some time. So here it is showing that this will take up to 30 seconds. Please remain on this page. And here our data source got created. If you click on data source, here you can see last sync time nothing, because we have not clicked on sync now. So just choose your data source and click on sync now. So what it will do in the backend, it will do all the processing. It will read all the PDF files from our source, which is our S3 location, and it will create the index for querying purpose. Okay. Now we are going to start writing the programming part. So for that, I have already opened here one particular Google Colab notebook, and the code will be kind of similar with respect to what we have written in our previous video. So I'll open my previous code of RAG application, and then I will try to modify that to make it compatible with Kendra search, right? So here this is our previous RAG application code. So first we were doing pip install Boto 3 LangChain Pinecone. So that obviously anyway we have to do in this case also. So I will run it, and then I will click on next line for code. And here what we are doing, we are creating the Beddrop Boto 3 client. So I'll copy this code as well, and I'll click on next cell. And here we are inputting some important modules or packages, whatever required. Now earlier what we are doing, we are reading the text file, and then we are splitting that into small chunks using characters text splitter. And then we were calling Bedrock embedding to get their vector representation to store in Pinecone DB, right? But now, as I told you, that Kendra is going to take care of all these things. So this part coding will little change. So here, let me search in Google LangChain Kendra. Okay. So here, if you search from LangChain how to use Kendra, that particular documentation we can explore. And here this is the code from LangChain community retriever import Amazon Kendra. So we'll do that. So here I can just import this thing, and then next step what it is doing, here we need to execute this code. So retriever.get relevant document, what is LangChain? So this is nothing but a question what we will ask in retriever. But before that we need to mention the retriever. So to create a new retriever, this is the code. Let me just paste it and then I'll explain. So here what we are doing, we are basically creating the retriever using the index ID of our Kendra index. So here index ID I need to update. So here if you see, I will go to index, and we are having this index ID just now what we have created. Okay. So this index ID I'll be providing. And now this Google Colab need to interact with Kendra, right? So for that, obviously some client needed for Kendra, which will help using access key and secret key to perform the authentication or authorization. So here we can explore Amazon Kendra code documentation. Let's see how to do that. And index ID, region name we can provide. And here we are having the option of client for our Kendra Boto 3. So that one we can pass, comma, client equal to, here I can write Kendra client. Okay. And this Kendra client we need to create. So here what I will do, Kendra client equal to Boto3 client, and we can put this particular code. So basically we are creating the client for our Kendra so that this Google Colab notebook can easily talk to our Kendra application. So for this we need access and secret key. So that we'll put security credentials, will go open in a new tab. And here already 2 access key secret key created, so I'll delete one existing one. And I'll create a new access key. And access key I'll copy and paste that for our Boto3 client in both places, and secret key also I'll copy. Okay, right. So up to this part is pretty much looking good, and here I can put response equal to like this, right? So now let's query once. So here Boto3 is failing. Okay, import Boto3, but we have installed Boto3, right? Boto3 client spelling mistake. Okay, and we can run it now. So it ran successfully, and here you can see that Kendra client is not yet defined. So because earlier Boto3 cell failed, so this step also failed. Now let's ask some question and let's find out whether Kendra can return us the similarity or not. So for example, some particular specific question we can ask. So here if you see Surakshit Bharat, here it is written 0 major terrorism attack in any city since 2014. So here I can ask the question like, how many major terrorism attack happened in any city in India since 2014? How many major terrorism attack happened in any city in India since 2014? Okay, right? And before running this code, let's see our index and data source is yet ready or not, because it takes some time to sync. So here you can see currently it is in succeeded state. Okay, so that means our Kendra index is ready. We can use this for querying purpose. So let's run it. So here still it is showing some issue. Kendra client is not defined. Here we have defined, right? Don't know, maybe some issue was there. So let's run it. Beddrop runtime object has no attribute retrieve. So here, okay, so this should not be Beddrop runtime. For Kendra we are getting, so it should be Kendra. So let's run it. So here you can see some similar documents it has returned from our complete PDF file. So if I just search 0, so here you will able to see somewhere it is written that 0 major terror attack in any city since 2014, right? So that means here Kendra is doing the same activity earlier what Pinecone was doing. So what we'll do now, we will pass this as context to our Beddrop model, and we'll ask the questions to Beddrop directly, so that instead of suggesting the relevant paragraph, it will give the exact answer of the question what we are asking using power of LLM. Okay, so here what we'll do, if you observe, this is the LangChain prompt code what we used earlier, that here are some input context which will help you to answer the question, and here we are passing the context and then human input we are passing. Okay, so here this prompt template only we are going to use. We are going to import JSON, and the next part here I will copy this thing and then paste that here. So earlier we were searching using similarity search. Now search results already we got it. From where we got it? We got it from this response part. So we can use this thing as our response set. So here I can put that search result equal to response, and then here we are creating the context string. Human input we need to provide. So human input equal to input enter the question. Okay, so here human input we have taken. We are creating the prompt data. We are passing via our Beddrop model, and here Titan we are using to get the output. Okay, now to implement this whole thing in one cell, what I will do, search results instead of response, I will put that response code also here. So response code is nothing but we are creating using this particular stuff. So instead of response, we'll put this thing. So using Kendra retriever, we are getting the relevant documents based on the questions, whatever we are asking. Okay, so here in this case, it will be human input, right? So now let's run it and let's see whether it is working properly or not. And here we ask the same question, that how many major terrorism attacks happened in any city from 2014. And here you can see it is replying there was 0 major terror attack in India since 2014, right? So based on the similar documents, whatever Kendra has found out, here our Beddrop model is taking that as input. So it is kind of, first we are doing retrieval, then augmentation. Augmentation is nothing but here human input and context string we are putting together to create our prompt data, and then we are going to generation string, right? So now let's go to ask some more questions, like for example, Modi ki guarantee for Nari Shakti. So here I can ask the question, what is Modi government's sankalp for women empowerment? Okay, so although in our PDF file it was written as Nari Shakti, but here you can see that we asked with women empowerment. And now let's see whether it is able to reply properly or not. So here this is what reply it is giving. To empower women in India, the Modi government has taken several steps. Some of initiatives include strengthening emergency helpline 112, and then apart from that, empowering women self-help group, and self-help group they are merging with one district, one product concept. So all this information from where it is getting? It is getting from this particular document only. Here if you see, if I just zoom this particular part little bit, here you will get self-help group with ongoing initiatives such as one district, one product. So from these kind of places, it is extracting similar results and it is trying to return us. So in short, what it is doing, it is basically encapsulating the step what we have done in this place, that is PDF files to index store. This middle part, whatever we were doing, that Amazon Kendra has done itself. We have done nothing, just we tried to configure our data source and we ran it. And then using this particular Kendra retriever, it is trying to find out similar sections of our document using get relevant documents, and using that document we are creating the prompts and that context we are passing before asking the question, right? So this is how it is working. So maybe I can ask one more information specific question. So let's see. So here one statement is that people's dream of 5 centuries of Ram Mandir in Ajodhya has become a reality. Okay. So here I can ask this kind of question. For how many years India waited for Ram Mandir? Okay. Let's ask this question. So here you can see it is giving the reply 5 centuries. Okay, right? So how it is giving? It is basically finding out the similarity with respect to this particular section, and then it is replying. Okay, so one more last attempt we can do. Like for example, constructed 3.7 lakh kilometer rural roads in village under PM Gram Sadak Yojana. Okay, so here I can ask the question, how much roads were constructed by for village? Okay, so this is the questions, how much roads were constructed by Modi government for village, and here you can see it is replying 3.7 lakh kilometer of rural roads in villages across India. So again, it is able to give the reply properly based on this PDF file. So like this way, you can use Amazon Kendra for implementing RAG application, right? I hope you understood this. This is all for this video. And don't forget to terminate any Kendra data source or index once your POC is done, because it charges a sufficient good amount. It is little expensive service. So make sure you terminate the index and data source. Like here I can do it. So here I can select this and then click on delete. Here you can mention something and after that you can click the delete button. So with this you can make sure that it will not cause you unnecessarily charge after doing the POC. So the relevant codes and the documentation links I'll be providing in the description box or in the comment section. You can try to play with it. If you have any doubt, you can ask in the comment section. I will try to reply back ASAP. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.